Okay, we're going to get started. My name is Laurel Ackerman. I'm on the AtScale marketing team, and I'd like to welcome you to today's webinar, Modernize Your SSAS Investment Without Giving Up OLAP. It's one of our most popular topics to date, and we're really excited. First, some quick housekeeping notes. This webinar is going to run for about 45 minutes. There will be time for Q&A at the end, and the recording will be available after the live event. We'll email it out to all of you, and you'll be able to find it also on our website, atscale.com. So now let's get into our main topic. SSAS challenges is a hot topic. We hear a lot about it. It's one that we're currently helping a large number of our customers with, and we hear about as we're talking to prospective customers in the field. And our presenter today is AtScale's founder and chief strategy officer, Dave Mariani, who you might already know for creating a 24 terabyte SSAS cube at Yahoo when he was there, eventually leading up to him not wanting to do that anymore and founding AtScale. He's definitely the right person to lead today's discussion. And with that, Dave, I'm gonna turn this over to you.
Great, thanks Laurel, and thanks to everybody for joining us. This is a topic that's very close to my heart. It is really the primary reason why I started the company with the rest of my co-founders. So really happy to be able to tell you the story and to actually show you where we've, what the inspiration was for the product. So first of all, thank you for, when you were registering, you had the option to ask some questions or give some feedback on the topics. And so in reviewing those comments, a lot of you said that you want to see how virtualization works with a multidimensional model like SSAS. So AtScale, of course, is a replacement for SSAS, and so I'm going to show you virtualization in this demonstration. You can see how it all works and blends perfectly together in a multidimensional environment. You guys also had some questions or confusion about connection to Snowflake. And I think one of you asked, do you have a driver for SSAS for Snowflake? Just to be clear, AtScale is a replacement for SQL Server Analysis Services for that engine. So yes, so it's not a driver. You talk straight to AtScale, and AtScale talks to Snowflake, and that's all done. For you behind the scenes. So we use Snowflake as our primary engine for satisfying the queries. And I'll show you that today because the demo is on Snowflake and Redshift. And then finally, you wanted to see us how AtScale works with Excel and Power BI. Obviously, if you're looking to scale up SSAS, you don't want to lose connectivity to those very important tools. I always like to say that I think Excel is the most popular BI tool in the world with 1 billion users. And as most of your organizations you probably know, the data all ends up in Excel anyway. So I'll show you that, and I'll show you those integrations and how it works seamlessly, just like SSAS. So I'm not going to bore you with a bunch of slides. I'm going to spend most of my time working on and showing you the product and answering your questions by showing you the product. But just a few slides to set up the architecture so you know what you're going to be looking at. And I also want to tell the story of Tau, of the Yahoo Tau Cube. Because again, it's a big inspiration and drove a lot of why the product is what it is today. And I'll talk about why I started AtScale and then get into the contrast with SSAS. So this is the Yahoo Tau platform. What is Tau? At Yahoo, Tau stood for Targeting, Analytics, and Optimization. So I got to Yahoo through an acquisition. So I was the CTO for a company called Blue Lithium, which was one of the first ad network providers. And so our analytics were excellent because I did those analytics with SQL Server Analysis Services. And so I got the opportunity at Yahoo of scaling that up from really 350 million ads a day at Blue Lithium to 3.5 billion ads a day at Yahoo. And so this was back in 2010. Big data wasn't a term yet, but we were definitely big data. And at the time I was there, it was a great time because we were inventing Hadoop. So Hadoop was our landing zone for all the log files that were coming off of our web servers that were serving our display ads across the Yahoo ad network, not just on the Yahoo homepages and sports and the like, but across all the web through our Right Media platform. So we were collecting a lot of data, two petabytes of raw data. And we were then mapping that data through basically hourly partitions. So doing the aggregation and the ETL using Hadoop and MapReduce, which was a great tool for doing that. We would produce files. We would then load those files into an Oracle RAC instance where we would load partitions, and we'd load hourly partitions that then would map to hourly partitions in SQL Server Analysis Services, where we would build the cube and then deliver that cube for consumption to our internal customers. So we had about 500 users of this particular Tau cube. That one cube generated $50 million of extra revenue for the AtScale display ad business, just allocated to that one cube. So it was a very valuable cube, and it made a lot of sense to keep that and get that data into the hands of our optimizers, our ad optimizers, as quickly as possible. So what is wrong with this picture? Well, the functionality of analysis services was amazing. The impact to the business was amazing, but getting and delivering and keeping this thing running was not. So the first problem is that what you see here, that we're condensing 2 petabytes into 24 terabytes. Now 24 terabytes was the largest cube. I think it still is by an order of magnitude of 5. The next largest cube was Microsoft's own MSDN cube, which was 5 terabytes at the time. So you can look at that and you can say, wow, SQL Server Analysis Services does a really great job at compressing data, doesn't it? It's like, no, it's not compressed. It is the fact that I had to drop almost all that data on the floor and leave it in Hadoop because I couldn't afford and I couldn't get it built into the actual cube. So for my business users who wanted to see full fidelity of every single ad so they could see exactly what the behavior was on users with those ads, I had to pick and choose what I thought was relevant, which is obviously not what I wanted. The other problem with this picture is the hops. So you can see that I have actually 3 copies of data at the end of the day. And we're talking about big data. So not only is the cost of storing that 3 times difficult, especially since I had to have HA, which means I had to have 2 data centers that were exact replicas of this. So not only was it stored 3 times, it was actually stored 6 times. The other problem is that there's a lot of moving parts and this stuff breaks. So if there's a problem moving the data from here to here, I'm out of luck and my users are out of luck. Loading SQL Server Analysis Services, I'm out of luck if I have any kind of problems whatsoever. And the best I could do was to refresh that data or update that data twice per day. 2, maybe 3 times if I was lucky. The third problem you can see with this picture is that it was a single server for analysis services. So I had to go and find the biggest server I could get because analysis services is not clustered. And so I had to make it fit on one machine. And this was back in 2010. I found a very expensive IBM server with 24 cores. And I bought the best CPUs and the most cores I could get, and that's what it was. On the disk side, I had to use NetApp NASes, so a network attached storage. And to make it worse, because as I updated the data in this cube, I had to create basically an A and a B cube. So the A cube would be serving traffic to my optimizers and my users as I refreshed the B cube. When that cube was done, when refreshing, I would then swap snapshots on my NetApp server from A to B. And now B would become the serving cube. and A would be now the cube that we refreshed. So that was complicated, and I got caught. One of my engineers accidentally deleted the snapshot, and because of that, I was out, and this platform was out for 7 days, for a full week. Why for a full week? Because it took 7 days to build this 24 terabyte cube, and that was for only 3 months worth of data. So for my users doing year-over-year analysis, they had to stitch together 5 quarterly cubes, which of course was not at all ideal. So what are my troubles with Tau? Like I said, stale data 2 to 3 times a day. If I could have gotten my users hourly data, or even just hourly data, let's just call it that, they could have increased that lift from $50 million to $250 million. That's how much it could have been worth if the data was more up to date. Because display ad campaigns are very short-lived. They typically only live for a week or less, which means there's not much time to squeeze that performance out of them. My users didn't have the full fidelity of those ads because, again, I had to pick and choose to make it fit on that one server and make it fit in terms of the cube build and the time it took to do that. It was very complex with 6 copies of data, including HA, and lots of points of failure, single points of failure, that took a lot of my engineers to watch and to pray. Limited dimensionality because I had to fit in one server. Very constrained scale, again, because of that 24/7, 7-day cube build cycle for 1 quarter's worth of data, and really bad agility. So it would take me anywhere from 4 to 6 weeks to add a new dimension to this cube. Not at all responsive to business demands. So this is why I started AtScale. You know, I started AtScale because I suffered all this like you probably do on the phone. Its analysis services was amazing for giving our users very fast performance and the ability to then do analysis that they couldn't do before to generate real business results. And so, but that didn't help me for my MicroStrategy users. My MicroStrategy users, 8,000 seats, were all running against Oracle RAC, and it was slow. I had my Click users in Europe that were building cubes, and they were building Click cubes. And of course, I had custom applications in my SSAS, and everybody, and I had to keep all these up to date, and they all had different performance levels across the board. My time to reacting to new business needs was way too long. It took 4 to 6 weeks because I had to remodel and model the entire pipeline and reconstruct the entire pipeline and test it. So it took 4 to 6 weeks to respond to the business. The cloud at the time was not really a consideration, but it definitely is now. So moving to the cloud from on-prem creates all kinds of complexity. We introduce a whole nother dimension of complexity, the dimension of location of data. Legacy platforms, I had them all at Yahoo. I'm sure you have tons. And then being able to deal with the variety of where data is stored is a nightmare. And then it came to just a single source of truth. I had no single source of truth because I had different BI applications and platforms all generating different calculations and different answers. So even the most basic metrics of the business, page views and ad clicks, and my MicroStrategy reports were different from my SSAS reports. They were different from my Tableau reports. They were different from my Click reports. So we had to staff an entire team of data quality experts to reconcile reports across the spectrum. Ridiculous waste of time. And then managing all these tools was a headache. So I couldn't double down. I couldn't build just one pipeline and do it one way. I had to support multiple tools with multiple constituencies, which required extra engineers for everyone. So we decided to start AtScale. And when we started AtScale, we decided to keep the good, but to toss out the bad. So what do we do? Well, first of all, we made sure that data movement is evil, and we want to eliminate data movement, and we set out to do that by leveraging the data platforms as the primary engine of our analytics. So wherever the data laid, wherever it landed, whether it's Hadoop, whether it is Snowflake, whether it is Teradata, whether it's Oracle, whether it's Google BigQuery, it should stay there. But what we're going to do is we're going to provide a single semantic layer that's going to manage performance and make those data platforms perform as well as they can, and make them behave just like SQL Server Analysis Services without having to physically build a queue. So we have the ability now to join together on-premise data platforms and cloud data platforms, and then serve all the BI tools with the same single source of truth. So no longer do we have to worry about Tableau telling a different story than MicroStrategy. We all going to have the same answer because we're all serving it through the same definitions, all defined on the AtScale platform, and all delivered in a multidimensional or tabular fashion. So we have a lot of customers, and a lot of these are sort of our key verticals, and they're all looking to modernize that infrastructure, just like you may be today. And most of them do love multi-dimensions. Some of them don't, and they just want to go tabular. With AtScale, you don't have to choose between tabular and between multi-dimensional. We got you covered on both SQL and MDX, and all these customers are enjoying that freedom. And the freedom from being stuck in one single monolithic BI platform. So where does AtScale fit? We're really that semantic and governance engine that's going to sit between your applications, your AI and BI tools, and we can access data from the data lake if you're in the cloud or you're in Hadoop. We can also front any kind of data warehouse, whether that be Spark on your AI and ML engine side, or on any of your cloud data warehouses like Snowflake, BigQuery, and Redshift. And of course, we can give you access to the raw data, so you can get clean data, raw data, all in the same platform, all consumed, and also all integrated with your favorite data catalog. So we have one semantic layer and one vernacular for the entire organization. And this is what the AtScale platform looks like as we explode it out. So again, we're connecting our consumers to our data platforms. We do that through a metadata layer. So we present what we call virtual cubes or virtual tables to these consumers. And these consumers can talk to this AtScale lightweight platform either through SQL in tabular mode or through MDX. And then the MDX side, we look exactly like SQL Server Analysis Services, which is where our discussion, I'm going to spend a lot of time on drilling down on that. And we designed the platform to really be a drop-in replacement for analysis services, to be a scale-out replacement for analysis services. So how do we make the magic happen? You're going to see our visual modeler that we call Design Center. And that's our equivalent to BI Studio and SSAS. You're going to see our multi-dimensional engine, and you're going to see we're going to show you federation today. So we're going to show you blending data across Snowflake and Redshift. We're going to show you our adaptive cache, our acceleration structures, our aggregation engine that will automatically tune queries and tune performance on these data platforms for you, without any extra data engineering. And you're going to see all that powered by our AI engine and our inference engine, where we're going to learn query patterns and respond to them and tune it. And you're going to see that happen on the fly. I'll also be showing you our extra security options. So besides single sign-on, besides the fact that we can talk to your underlying data platforms using, using delegated authorization, we also add perspectives on top of that for locking down your metadata. We also have row-level security and of course, single sign-on. So What's the difference? What I'm going to show you today is that rather than having to import data into a single and build cubes in SQL Server Analysis Services, or then I have consumers going against SQL Server or going against a data marts or data warehouse or data lake, you're going to see how AtScale is going to be able to front all those data sources and do all that virtually. And you're going to see how I'm going to show you a bunch of different tools here for how we connect. And you're going to see the exact same performance, the exact same definitions of that data, and the same results, regardless of the tool we're using. So what are the key differences, which we'll point out today? On the scale side, we're not limited to the resources of AtScale. AtScale is a lightweight pass-through platform. We're going to scale with your underlying data platform. So if you're on Snowflake, you can scale your Snowflake warehouse, you're scaling AtScale. It's all done the same. There's no such thing as scaling AtScale. The interface, you're gonna see a full interface from SQL to XMLA to REST. You're gonna see it done in a no data movement fashion. You're gonna see not just aggregated data, but you're gonna be able to see access and get access to the atomic data. Because we haven't pre-computed it, you can always get access to the fine grain. I wish I had that at Yahoo. And you're gonna see modeling, both multidimensional and tabular. It's not either or. You have both in one. And you're gonna see that we are built for multi-user. So one of my big difficulties and the thing that really hurt my agility at Yahoo was that I could only have one engineer work on the tau cube at a time. That was just not scalable. And very frustrating. With AtScale, you can have multiple users building virtual cubes, working on the same cubes simultaneously, and I'll show you that. Of course, you know, we all love multidimensional, at least I do. And these are the reasons why, for those out there who don't know, why do I need OLAP in today's modern day and age? Well, this is why we need OLAP. Do you wanna do per members per month, which is the key metric in the health insurance industry? That's an OLAP calculation. You want to count unique customers? Hey, that's a semi-additive measure. That's OLAP. You want to look at store versus region performance, where you have to have level metrics? That's OLAP. You want to do credit fraud detection, where you have dozens or hundreds of different attributes? That's dimensional. That's multidimensional. You want to do this year versus last year, or running totals? That is time intelligence, and periods to date. That is OLAP. So all those things we need OLAP for, and that comes out of the box with AtScale. Not only is it going to be more functional and give you a single semantic layer, if you're looking to move to the cloud, you can look at these, and this is you can request from AtScale and from your contact. You can ask for these reports on our TPC-DS benchmark we did. And I'm going to show you the performance on a 10 terabyte TPC-DS instance on Snowflake with AtScale. And these are the numbers that came out of it. Anywhere from 4 times to 12.5 times faster on a single query, up to 61 times faster and more for user concurrency, and up to 10 times cheaper on compute costs, all with giving you much simpler queries and a much better and consistent interface. Okay, enough of talking. Let's get into this, and let's go through our demo today. So today, what I'm going to do is I'm going to basically take you through a 2-step process. We're going to define. I didn't use build. We're not going to build a cube. We're going to define a virtual cube. We're going to publish it, which makes it available for query. And then I'm going to show you, as a business analyst, I'm going to show you how we can explore and use that virtual cube to do some real analysis. So I'm going to be playing 2 roles in this demo today. I'm going to play the role as a data owner or data publisher using Design Center, AtScale's design environment, and I'm going to be a consumer and a business analyst at the same time. So let's get busy. So first thing let's do, let's just go to Design Center. So this is really AtScale's really heads-up display for managing your virtual cube environment. And the first thing I'm going to go is I'm going to go to my settings page and click on my data warehouses so you can see how this is working. So what I've defined today for my demo is I actually have 3 different data warehouses. I have Redshift, I have my Snowflake instance or warehouse where I'm actually doing my benchmarks. And I also have another Snowflake warehouse instance where I'm going to be doing my other demo. So you can see here, not only can I have multiple engines by creating new data warehouses, I can create new data warehouses of these types and just fill in the credentials, and then I'm off and running. And that means I can now design on the design canvas, I can now access those data sources and build virtual cubes. So if I come back to my home page here and I look at what's going to be my equivalent of AdventureWorks, you can see here in my data sources pane, you can see those 3 warehouses: Redshift, Snowflake Benchmark, and then Snowflake. And all you can do is you can go ahead and explore, and that all becomes automatic. There's nothing to load in AtScale. There's no metadata to synchronize. It's all live. Okay, so let's start with how do I get started and how do I define a virtual cube in AtScale? Well, if I come here in my quick start page, you can see I can define virtual cubes from scratch. I can actually download samples from our website and which come with sample data as well as sample models. I can actually import XML, so XML to define those cubes. I can actually import models from my Tableau workbooks, from a whole zip file of Tableau workbooks, and we'll actually create models, a consolidated and a AtScale model for you. And I could also import cubes directly from SSAS using the XMLA file for that cube. So let's go and do that. And I want to just show you that Tau cube that I've been talking about. So let's see, let me come back here to, oh, here it is right here. Here's my Yahoo XMLA cube. So this is how you can actually import a SSAS cube definition right in AtScale without having to go through and recreating it in the AtScale model. So I'm going to call it Tau. Again, it was called Targeting, Analytics, and Optimization. You can see that we detected in that XMLA 40 dimensions, 412 attributes, and 77 measures. So quite the big cube that we have built there. And you can see we have some warnings that you can go through here by scrolling through, and we can tell you exactly what we found and what you might want to look at. You can even download the full report on this conversion. So I'm going to go ahead and accept that. And now what I have is I now have a Tau cube in AtScale. Simple as that. This is my Yahoo cube. And so there it is. So let's go ahead and I'll just go ahead and rearrange this. I'll zoom in so you can see all its glory on this. There you go. So there's the Tau virtual cube. And you can see that it's quite the big model. The greens represent the dimensions. You can see just how big that advertiser dimension is. The blues represent the fact tables. I think one of the questions on the calls was, how do you deal with multiple fact tables? Hey, you design it right here on the canvas and you build it from the top down. You can see all our dimensions and all their glory and all measures in our preview pane. This is what the BI tools are going to see. So you can see our dimensions and our measures all laid out here in folders, all designed in SSAS and now available for query in AtScale. Now, of course, I don't have access to the Yahoo data, so this is just the model. So let's go and deal with some data that we do have. So I'm going to come back to my my quick start here, and I'm gonna build a cube from scratch. So let's go ahead and let's reconstruct AdventureWorks and the AdventureWorks model. And so I'm going to go ahead and do that. And not only am I going to do that and reconstruct it with a brand new cube, I'm also going to show you what it looks like and what the contrast is to how it looks like in analysis services. And this is AdventureWorks in analysis services, okay? So let's go ahead and let's create a new cube. Let's give it a name. We're going to call it SSAS demo. And I'll add it. Okay, so there's our SSAS cube. And now I'm going to go ahead and enter the canvas. We call this the canvas. You can see right now I have no dimensions and measures because I'm actually going to go ahead and define that on the fly. Okay, so what is the difference here? So let's go back to the way we would built it in analysis services. Well, in analysis services, you can see that we have the data source view. So this is where you're actually defining basically what your ERD diagram is. And then you have your measure groups, and you define your measure groups. Your measure groups pretty much align to a fact table. And you can see in the measure groups, if I just look at those, it just gives me a list of the columns that I've exposed. And then you have your dimensions, and you define your dimensions. Like here's my customer dimensions, for example. And then to put it all together, then you go to your dimension usage, where you then take your measure groups and you align it with your dimensions. Now, and then you have your calculations, and your calculations are defined over here. And you have calculation scripts. So what I found in this process is that what I loved about the fact that it's object-oriented and it promotes reusage. That's a good thing. What I didn't like is I didn't like the fact that it's a bunch of parts. You basically dropped a bunch of parts on the garage floor, and then you're asking the customer to build the car from a pile of parts. So we took a different approach at AtScale to make this and to make defining virtual cubes much easier. So let me show you how I would define this cube in AtScale. Well, first I'm going to go to my, my Snowflake data warehouse, and I'm going to explore and look for some data to use and define this, this virtual cube. So I'm going to go to my AtScale schema, and this is all in Snowflake, by the way. And I'm going to go ahead and start by pulling in my sales logs. This is fact internet sales, the fact table. I'm going to pull it onto my canvas. So by pulling it onto my canvas, AtScale is automatically going to create what we call a data set. So this is the data set, and this is that table. It's important in that you can see all the columns here. I can actually double click this, and this is actually going to put me into a data wrangling view. So what I'm going to see is I'm going to see the raw data, and I'm going to see all the raw data, and I can see that in this case I have key value pairs for product info. You can see sales reasons is an array. It's an embedded array in a string field, and here's all my date fields, and etc. This is all my sales data. But what I can do with AtScale is I can do wrangling, for example. Let's say that I want to do a replace, and I want to replace all those nulls with, I don't know, maybe a -1 instead, because I want it to be a number. So I can go ahead and do that, and I'll create that transformation right in line in the model. So there we go. Now my nulls are -1s, and I can go ahead and create that virtual column, and I can use that virtual column. I can also create new calculations. Like let's create a sales tax. And my sales tax is going to be my sales amount times 8.5%, because I'm in a high tax area here. That's 85%. That's 8.5%. So I can go ahead and test that syntax. That's going to be passed straight through, in this case, to Snowflake. So that's a pass-through query. I don't have to create any kind of the construct. And there's my sales tax as now a new metric that I can use. So now I can click back on this tab. And if you look at my data set, it now has this new calculated column associated with it. So this data set is now a reusable object that I can now reuse, and I can reuse the sales tax across multiple virtual cubes. So it's a great sharing model that goes beyond what we had in SaaS. So I can now create a measure by dragging it in, and now I have my sales tax. And you can see that I have my sales tax, and I can set a bunch of attributes here, all within this particular dialog. So now if I look at my preview, now I have sales tax. So how do I add more measures? I don't create measure groups. I simply say, I want to be able to report on order quantity, and I want to report on sales amount. And I want to do something I couldn't do at Yahoo, which is I want to count customers. and I want to count distinct customers. At Yahoo, I couldn't do this with SSAS because counting cookies was not, I couldn't get it to scale, even with all the work that I did. With AtScale, if I had it, I could simply choose a distinct count, and now I got it, and it's going to perform at scale just like a sum or a count would. So now I have some interesting metrics. What about dimensions? So let's go to our library. So this is how we do our sharing, and I'll filter by dimensions. You can see I have some dimension objects defined. So let's pull on my date dimension onto my canvas. Let's go pull on my product dimension, and let's do my customer dimension. Okay, so now let's go in and contrast how this all works. Well, the way that we do the relationship is not through dimension usage. What we do is we simply drag and drop. So my date dimension, for example, I have my order date key. If I go ahead and drag that order date key on top of my date key, and I say it was an order as a prefix, what I will just have done, as you can see, is that I've now created a role-playing dimension. So you can see that this order date hierarchy with a bunch of different calendars has now been inherited just by dropping that field on top of it. And I can do the same thing for my ship date. By putting in a prefix, and AtScale will automatically create a role-playing dimension for you. Very easy, very obvious to do. The product dimension, let's take our product key and hook it up. And voila, just like that, I now have product in my cube. And I know everybody is going to be using the same product dimension across every virtual cube in every project in AtScale. Now, what about that customer dimension? There's my customer key. And that customer dimension, if I look at that, you can see I have geography. It's also been part of that. Well, how did that come in? So now let's look and contrast this. This is my AdventureWorks model. But if I double click on my customer dimension, you can see that my customer dimension has two embedded dimensions, a gender dimension and a geography dimension. So that geography dimension has its own model. And so I'm able to embed dimensions within dimensions, which makes it a much more effective reusable model, as opposed to the customer dimension here in analysis services, where I'm having to reinvent the wheel and remodel the wheel every time I want to use gender, for example, in a particular dimension or view or hierarchy. Okay, what else can we do with this model? Well, let me show you something I couldn't do with analysis services, which is like, you remember we had if I go back to my preview of my data, remember we had some key value pairs? We have nested data, and there it is in product info. We have size of 62, weight of 15, etc. Normally, I'd have to write ETL and bust those things out. With AtScale, I can actually extract them in place. So I can say, for example, I want to create a dimension on color and a dimension on style. That's going to create virtual columns you see there in my data set, sales log. Now to turn them into dimensions, I'm not creating dimension tables. All I need to do is go ahead and drag them into the dimension panel. And now I have color and I have style as dimensions in my virtual cube, without having to build dimension tables, without having to go through the process of building a whole new dimension and creating a whole nother relationship. Okay, let's go and let's actually explore this now. So I'm going to go back to my project here, and I'm going to publish that project. Publishing it means making it available for query. So, and I can publish multiple versions of this, so I can then do development on one without affecting my production. Again, something very difficult to do with analysis services. So I'm going to go ahead and I'm going to connect, and I'm going to first explore that new cube I just defined, and I'm going to explore it through Tableau. And I'm going to log in to Tableau using Tableau's built-in SQL driver. So first point of difference, we're not connecting through MDX, through Tableau. We could, and AtScale supports that, but we all know that Tableau works better in tabular mode. So what I have here is I have that virtual cube that you just defined, SAS demo, and we just defined here. and now it's available for query. So without building any cube, I'm going to go ahead and I'm going to run some queries. There's my order quantity. Here's my product hierarchy that you saw. So let's do it by product name. And I'm going to run a query here by product name. Oh, wait, I just forgot. I told you I was going to show you federation. So let's go back, and I forgot about this, and let's go back to my SAS cube here, my SAS demo cube. And I just did federation without you even noticing. How was it federation? You see this product dimension? You see that icon? That's coming from Redshift. And everything else is coming from Snowflake. So somebody defined the product dimension in Redshift, and all I had to do was use it. And just like that, voila, if I look at my Tableau query I just ran, there I have order quantity, which is coming from Snowflake, and product name, which is coming from Redshift. That was a federated query done without you even noticing. So let's keep going. Let's go order quantity. Let's look at our dates. Remember our role-playing dates? Let's look at it by year. Let's keep by year, by 2008, and we can drill down. You can see the performance is really nice, and it's getting even faster. Let's go and look at, remember color was that key value pair. Let's run a query on color. And there you have it. And you can see most of my products don't have color as an attribute. And we're able to do that without having to create a column for color. Okay. Well, first of all, what's happening behind the scenes? I want to show you a couple things. So you remember the query that we did do? In Design Center. I'm going to my query screen in Design Center. And I can see all my user queries that we just ran. So let's go back to that first query we did that was a federated query. So here is the query that we intercepted from Tableau. You can see that Tableau thinks that we have a single table called SAS demo. And if I go back to Tableau and I go to that data source, you can see it here. Tableau thinks there's a single table, and you can see that we're connected live. There's no data extracts here. And then you could see that we actually ran a consolidated query here. And then you could see we ran a query remotely on our Redshift and our Snowflake instance. So that query ran remotely on those instances. Now what happens? You can see that took 24 seconds. That's not acceptable. Let's go back to that first query we ran. And I'm gonna hit a refresh here. And let's see what happens. It actually did refresh it, trust me. I'm gonna go ahead and refresh this screen. And now you can see that same query ran in under a second. Why did it run in under a second? You can see it's the same exact query coming from Tableau, but this time in the query, we actually computed 2 aggregates. And I can look at those aggregates, and AtScale figured out exactly how to optimize this. We created a 158 row aggregate, and you can see that aggregate, we chose to build that aggregate on Snowflake. And you can see the other aggregate, if I come back to that other aggregate was also on Snowflake. If I look at that and click on the second one. Why? Because AtScale determined that it was best to position that dimension table right next to the facts. So there you have it. AtScale already got busy and already optimized and did autonomous data engineering without you even noticing. And AtScale is going to keep those aggregates up to date with the underlying data from this point on. Okay, what about changes? Let me show you what used to take me 4 to 6 weeks to do at Yahoo with Tau. Let's say I want to add a new dimension to this virtual cube. Let's go ahead and look at those key value pairs, and let's add another one on size. And let's create that. There's my new virtual column. Let's go ahead and drop it in. All I need to do to make this live now is to go ahead and publish it. So we'll republish that virtual cube. Voila. I'm going to go back to Tableau. Let's go back to my, my color query and watch what happens. You see there's color and style there. I'm going to cause Tableau to refresh and watch what happens. There's size. So instantly I have a new dimension or a new attribute that I've added to my cube. And now I have the ability in seconds of being able to do analysis on size and color for all my products without a cube build and without engineering and without retooling my entire data pipeline. Okay, that's great. What about other tools? How does it work in Excel? Well, that's the beauty. Because we look to Excel and to Power BI exactly like analysis services. So let me show you how we actually connect live through Excel. Come on, Excel. Show me how I can do this. Okay, let me close Excel and bring this back up. Okay, I'm going to connect to Excel the same way I would connect with Excel for a live pivot table through analysis services. And for some reason, it's not letting me do just that. I think because it's, oh darn. So I would click through other sources and click and select the analysis services connector and plop in the AtScale URL, just like I'm about to do right here in Power BI. So in Power BI, I'm going to go ahead and I'm going to do a get data. I'm going to choose the database choice here. And I'm going to see that there's actually an AtScale cubes selection. That's going to bring me up to my server. That's where I'm actually going to paste the AtScale URL. So that's just the XMLA URL. You're going to notice I'm going to do direct query. So I'm not going to do import. So I'm going to do a live connection here through Power BI. So that's going to read the AtScale metadata. And what you see here is that there you see my, my Sales Insights cube, and there's my SaaS demo cube that I just defined. So just by doing that, I now have live access to get the same answers and the same performance, all with the same security, all done through, Power BI instead of Tableau in this case. So let's go ahead and do that same query. Let's go ahead and do it this time through Power BI. We'll look at order quantity by color. So let's do that so you can see the same answer. Okay, here's my AtScale metadata. Let's look for order quantity, and there it is. Let's look for color, and there it is. And just by doing that, what you see over here on the right is that you see you now see Power BI with our same results that we had before. So there you go. There's your color order quantity by color, and it's the same exact answer as that you see back here in Tableau before I change my report. There you go. Okay. So, so what about, I'm sure you're all saying, hey, that's great, Dave. You're using AdventureWorks. AdventureWorks is small data. So what I'm going to give you the treat to show you this working at 10 terabytes of raw data on 28 billion rows. So I'm going to come back to Design Center here and show you our TPC-DS benchmark model that we use to produce our report. Please ask your account executive or your contact that you've been talking to for this report if you want to see the full report. So here's the AtScale virtual cube that's built on that. And you can see that we have multiple facts because we have web sales, store sales, catalog sales. This whole model has been defined and built into a beautiful, accessible virtual cube without having to write raw SQL. So, so to use this cube, let's come back. Let's go ahead and close this out. And let's open up that model in Tableau. So I'll open up the model, and I'll open up the benchmark model cube. And I'm going to log in with my credentials. I'm logging in now to AtScale. And again, this is the sample data set that comes with a Snowflake instance. So just to show you the raw data, I'm going to come back to my Snowflake. Here's where it is in your Snowflake instance. It's under Snowflake sample data. And under Snowflake sample data, you're going to be able to see there's different schemas. We're operating against the TPC-DS 10 schema today. So here's the raw data. So all I did was define an AtScale virtual model directly on that Snowflake sample data. So let's go ahead and let's look at, you can see I got my store measures. Let's go and look at a row counter. So we can see that we're dealing with 26 billion rows of data. So let's go and let's do some queries. You can see all my role-playing dimensions for dates here. Let's go and look at sold date, and let's look at sold date by year. These are live queries. It was that fast against 28 billion rows. Let's look at by product. So let's go to our product folder here, and let's look at our product dimension for which we have product category. Well, there's all my categories. Let me just change this so you can see it better. And there's all my rows by category. Let's go ahead and let's keep sports. And now let's go and look at my product class by sports. And there we go. In sports, we have different subcategories, including golf. Let's keep golf. And let's see if rich people only play golf. So we'll go to our demographics folder and let's look at household income by sports, by golf. And there you have it. Of course, the data is not interesting because it's all generated by the TPC-DS model. But you can see and just prove that this is not a Tableau extract. You can see that it is a live connection to a single virtual cube. I can go back in Design Center and I can go back to my query screen, and what you'll see right here is those queries that I just ran. So I just ran that a few seconds ago, and you can see that there's my model, there's my query I just ran against TPC-DS, and then that's how fast it ran. It ran 2.2 seconds. Why did it run in 2.2 seconds? Because AtScale got busy. It built this aggregate. That aggregate is about 6.9 million rows. It highly compressed. We are saving you tons of money by not causing compute on Snowflake. We're able to run on a small Snowflake cluster. If I look at Snowflake here for one I'm running on in my data warehouse, you can see that on my benchmark, I have actually 2 instances of Snowflake data warehouses. I have a 1XL and I have a small. Those interactive queries are all running against a small Snowflake instance, which means I'm only using 2 credits as opposed to 8 credits to actually build aggregates. So AtScale is smart, is always saving you money, and it's always saving you time. Okay, so I think that is a good sort of whirlwind tour of just what you can see through AtScale. And what I'll do is I'll hand that back to you, Laurel, for any questions we might have.
Great, thanks, Dave. Lots of great stuff in there as usual. We have about 6 minutes, so I'm going to go through the questions that we've had come in. The first one is, how do you model data across multiple fact tables?
Multiple fact tables. Well, let me show you that because that's a good example in the benchmark model. So let's go back to that benchmark model for a second. So the way it works in AtScale is that we don't have to worry about measure groups. All we do is we just define our relationships. And if we have common relationships, and if I look at that and I explode this out for a second, those common relationships all are, you can see down here, sold dates and ship date and customer. AtScale will automatically union multiple fact tables together using those relationships. And that's the beauty. So there is no extra thing that you have to do to make that happen. Now you could see that we actually did calculate different, we have, for example, store measures. So I can see just store sales quantity and average quantity. And then we can actually create calculations on top of that to add them together. So let's go back and look at our calculations here. And I can see, for example, that I have a total net profit. And if I look at that calculation, this is just a little snippet of MDX that adds together my net profit from store sales, web sales, and catalog sales. So it's very, very easy to combine data across multiple fact tables because of the power of AtScale without having to move data or consolidate it.
Excellent. Time for a couple more. Here's one. While AtScale serves great purpose for business users, what is expected on data infrastructure to support the complex queries?
Yeah, complex queries. Hey, one of the things I loved about analysis services is that you could do really complicated things through MDX and save a bunch of ETL. So a couple answers to that. First of all, you saw through our calculations, we can create calculations in a couple places. We can create calculations on the data set, and like you see here, like we created some tiering, like so, or I can create calculations post-query using our calculated measures and using raw MDX. So if I go back and I look at that MDX and I look at an example, let's look at, for example, web and catalog sales price growth. Well, let's go ahead and look at that formula. And here you see a MDX calculation. So you can see we took the web and sales extended price and we divided it by a parallel period calculation that will look at this particular dimension, the sold date. So we're looking at a sold date dimension, and we're looking at it at the current member for the sales price. So by doing that, I've now created a time-aware calculation that will work with any date combinations. And what's beautiful about that is that you don't have to create a set of metrics for this year or last year or year to date. With this kind of calculation, it's reusable across it, which saves your engineers and your data engineers a ton of time because they don't have to create new columns and new tables to do something like time intelligence. And it gives you, the designer, the cube definer, it gives you the power to act on your own without having to wait for IT.
Fantastic. We are just about out of time. There's a few more questions that came in that we're not going to be able to answer today. What we will do is make sure that when we follow up with the webinar recording, I will include an email address that you can direct all direct questions to so we can get those answered for you. It is hi@atscale.com, hi@atscale.com. Please feel free to send anything that got unanswered today our way. We'll go through everything that came in to make sure that you have a way to get the information you're looking for. So we're just going to wrap up. Dave, thank you so much for this excellent walkthrough of how organizations are leaving behind the challenges of SSAS and keeping all the great benefits of OLAP, as you've seen. Thanks to everybody for joining us today. We will be in touch shortly with the recording of the webinar. And we'll see you next time. Thanks.